Hey, Oles, welcome to the UltimateQA podcast. Super glad to have you. How are you doing today?
Hi, Nikolay. I'm doing well. Thanks for asking me to visit your podcast.
Yes, of course. My pleasure, my friend. Oles, I invited you to the podcast because you are one of our top automation engineers over here at Ultimate QA. You've been working with one of our large European customers for what's it been now? Almost 3 years. Is that right? Or 2 years?
Yeah, like 2 years, I believe.
Yeah, almost 2 years you've been working with them. You've done a fantastic job, and you've seen a lot of very cool stuff. You've seen the system being migrated from a legacy internal architecture that supports a bunch of different modules, right? Like this organization, they're supporting like their entire organization, really, the finance modules, legal, HR, transportation, logistics. They have a bunch of modules that they're transitioning to the latest technologies. And it's been a multi-year project, and you've been supporting it. You've seen a lot of very cool and interesting things. And I wanted to have you on the show to discuss what you've seen, what you've learned, some of your challenges, some lessons learned, because I think within those 2 years, you have so much wisdom in your head that I want to extract it out for the rest of us to benefit from.
Okay, great. I would like to share this with you. Yeah, what specifically we can start from?
Yeah, absolutely. I think a logical place that makes sense to start is maybe give us like a high level overview of the project that you're working on, what kind of applications you are supporting. And then after, I would love to talk to you about like their SDLC process and how it works over there and how you're assisting.
During this period, I supported multiple projects actually. They are part of some business system unit. I would say first project is related to supply chain. It's important unit in like I would support to every country. Okay. And the second one is related to internal usage, but giving some recommendation to and feedback for organization and their departments as well. And the third one is core here. And it's really important to get things over and connect all of the existing integrations of all organizations, software systems, I would say. It's having HRs, mentioned the logistic apps, the app I mentioned with recommendations to platform and lots more. And we approached them basically on different ways because first two system I mentioned is struggled with UI automation things, especially with end-to-end flows, because it took too much time to their persons who is responsible for setting up those tests, this test data, and going further with the output and the results of these tests. And when I took first try myself manually to just go over one of workflows in one of the supply systems, it took me almost an hour. It's fair, maybe because this is the first try. But then even when I got familiar with it, it still took me a lot of time, like having more than 5 minutes or even 10 minutes just to reproduce this test on my own, going through tabs, remembering the data I entered and stuff like that. It was a pain. Imagine having tens of these scenarios. And then I understood why those people struggled with this issue, with having the testing here and preparing the data and finally go through this flow. But yeah, things get well. After a few months, as we set up a process with team, have prepared the test plan, test strategy here for them, which they were satisfied. And yeah, basically pick the right tools. We picked the Playwright, maybe because it would, or maybe it already outclassed all testing tools, especially web testing. So I want to mention, in the market now, and it lied well in this project. And yeah, basically we covered the test and reduced a lot of manual effort, I would say, especially when we done testing on CI with parallelization and having tens of tests executing in 10 minutes or like 20, 10, 15 minutes. It was a nice result. Yeah, and having the almost the same picture with the recommendation platform, having also end-to-end test flows to go. This especially this environment is one important thing is they had multiple roles, and it added an extra complexity to preparing test automation framework because we need to manage multiple tests and browser sessions at the same time while one user do their actions and preparing some data or sending some request, and this information should be available to different user in the same flow. But yeah, we managed that as well. And yeah, of course, the time were reduced, and to reproduce this flow, it was painful as well. Like, imagine you put login as one user, then you need to log out, remember and find the credentials for different user, and and in third stage you want to log in as user number 3 and remember all those credentials, managing this web state and not to mess up was also some kind of pain for those who requested this help to automate this end-to-end scenarios. And the final one project, we focused not on UI testing, but on API testing, especially on how the integrations will work. And we prepared special API testing approach here. What I mean by this approach, we included what type of testing we would carry on APIs. They have like different ways, like sending malformed data, happy pass, security tests, like different combinations of security related headers, some missing information, nullish information, some fuzzing, as well as GVT forging and different techniques with replacing or managing or signing GWT tokens as well. Yeah. And it prepared us a lot of tests and helped us to mitigate some risks like we had in past, because when we started work with this project, I've seen the issues like someone forgot to put a policy on a API integration. Policy says that you can't send a request if you don't have at least client ID and client secret. And sometimes someone of developers could miss that out. And you can, when I tested manually first, I was what's going on when I send the request with invalid credentials, and it passed. I think what happening? But then we realized we speak with our manager of this project, and yeah, we prepared the traceability matrix, what can be parameterized here, possible ways to parameterize security headers as well as query parameters. And we did also nice job of, I would say, contract testing, schema testing. What I mean here, we had a living documentation as mm, uh, OpenAPI standard that gets updated in code as soon as it updated in the environment, in development environment. What I mean is whenever changes in their platform of developing integrations or REST APIs occurs, and whenever we get to our code and execute at least one test, we automatically have the latest structure of APIs, query parameters, response bodies, everything related to schema. These things get things much easier to maintain, because first we started to update those schemas manually, and it was real pain. But when we have this like living API schemas, we had less bug rate, especially related to schemas, because schemas updating really so much times, I would say. Yeah, because integrations are moving, changing. We had most of bugs related were about like non-compliance to schemas between integrations, between systems. And this approach helped us a lot, I would say. Yeah, at the end, we get to almost 1,000 of tests, API tests that are running quite quickly. We separated runs in functional test running and security test running, having tests as part of a build process to quickly check if a developer's not missing things in maybe some policies setup and stuff like related to security. And having functional tests whenever we make a deployment, we trigger testing as part of this process, and making sure that when the new app version deployed, nothing is broken in our current setup. Basically, something like that.
Wow, amazing. So much information you just unloaded. I love it. I have so many questions. I wrote them down over here, trying to think. So just to summarize some of the things that you said, because we can also talk about the technologies. You basically supported a number of different technologies. One of them is One Network technology, which is like a logistics software that is used to send stuff all over the world. Another one is MuleSoft. That's the API platform that you're supporting, and MuleSoft allows the engineers to build integrations with a bunch of their different services that are supporting the entire organization. Ultimately, all the backend systems and backend and front end, I guess, systems, they're all integrated through MuleSoft. And then the third one that you're talking about is that Appian, the complicated workflows using numerous users. Appian platform, it's a low code development platform, right?
Yeah, right.
Cool. Okay. So now talking about that technology, that's amazing. I want to cover a number of things here. I know that we have a dashboard that we built that shows a bunch of different metrics and what we were able to achieve. So I'd love to show that. We also did initially a POC comparison of the type of tooling that we should choose for the organization based on their current needs. I would love to show that as well. So we'll show that in a moment. And then, of course, we'll talk about our CI/CD pipeline that I think it's good and mature in the MuleSoft platform and the automated APIs. And then we can go in any of those directions deeper. So here is a POC tool comparison that we did initially for the project. We were initially brought onto the project in order to do automated software testing. But first, we had to figure out which type of tooling we're going to use to support the requirements of the organization. And this is where I see a lot of engineers making mistakes by picking a tool that they just know best and using that tool as the answer to everything. And I think that is a huge. I made this mistake for years in the beginning of my career. I learned some tooling, learned some programming skills, and I wanted to stick with that. And that's a huge mistake because not every tool is correct for every situation. In fact, organizational technical environments can be so complicated and different that all the time it makes sense to reevaluate your tooling to see if it is the best for the job. Will it make your organization the most efficient? Will it make it easier to work with the developers? Will it make it easier to do reporting? Will it make it easier to do automated API testing? Maybe you don't need API testing. So then you're looking at other types of tools. Maybe you only need API testing, and API testing is the priority and the primary thing that you'll be doing. So you're looking at other types of tools. All of these things are very important to consider. And so we created this evaluation metrics and criteria dashboard that we ultimately use to make a decision between 4 different technologies. Originally, the organization is a .NET shop. They use all Microsoft technologies. And so we, of course, use C# and 2 different types of tooling, whether it's Selenium, which is initially what they wanted to use. But with my recommendations, I said, hey, let's explore some other tooling, some other latest tooling that exists out there in the world. Playwright was relatively new to the game and had some good traction. And so I recommended we trial that. And then, of course, the top 2 JavaScript toolings, which are Cypress and Playwright, we decided to go with TypeScript because I think that's more common these days in the Node.js environment. We wanted to evaluate those as well because those are known as really good tools. Could they do what they wanted? And actually, at the time, Cypress was my favorite. Having used a bunch of different types of tools, I really enjoyed the Cypress experience. But ultimately, this is exactly the lesson that I was talking about. It doesn't matter what my favorite tool is. Once we evaluated all the criteria based on our scoring, Playwright with TypeScript won out based on what the organization needed, based on what we needed to automate. Like here are the different applications that we needed to support, for example, and Playwright ended up winning out. And ultimately, I think it made the most sense. Like, I don't know if you would agree, Oles, but I think the amount of success that we've had in the project part of that is tied to the tooling that we chose, which was Playwright with TypeScript. Do you agree with that
Yeah,
statement?
definitely agree.
Yeah, I'll give some examples. Like, for example, Cypress with TypeScript. For Salesforce applications, which are known to change domains a lot, it made it really hard to automate with Cypress because Cypress wants to stick to a single domain. It's meant to be really be used basically by developers working in their local host or other environment and staying at that URL and working with that single page application, for example, not really navigating. But Salesforce doesn't work like that. And so that's why you see we gave it a score of 1 out of 4 because it was the worst at doing Salesforce automation. It was better at other things. But Playwright, for example, handled this kind of situations no problem. And in fact, it handled a number of different applications with no problem. Playwright with C Sharp also did a decent job. Playwright with C Sharp ultimately ended up losing out because, unfortunately, I come from a C Sharp background and I love C Sharp, but it doesn't get the love and support that TypeScript gets. And so, like, the features that you see on the website of Playwright, when you go to try to use them in C Sharp, most of them don't work. They work in TypeScript, but they don't work in C Sharp. It is what it is. It's the reality. And again, it just points to the lesson that if I picked my favorite tech, it probably would have been Playwright C Sharp or Cypress TypeScript. And then the customer, as a result, would have suffered by limited testing capabilities because of my biases and my inability to be objective and evaluate tooling based on the needs of the customer.
Yeah, totally makes sense.
Okay, cool. Anything else to add from there, Oles?
Here, yeah, the number says everything.
Yeah, exactly. The numbers are objective, and so it's nice. And it may not be true for every single organization and every different environment. Like I said, you might go in and, for example, you might realize that API testing is the only thing that's important for you. And so then maybe even picking Playwright with TypeScript may not be the best. Maybe there is another technology that is better suited for automated API testing. And I'll throw out another example. Maybe your entire team doesn't know TypeScript. And so, but they know C Sharp, for example. And so then you have to make a decision about whether you want to train them on a new, latest and greatest technology, which will involve training them in a programming language, or do you want to leverage a mediocre technology, but on a programming language that everybody knows? And I actually might lean towards the latter because I think programming skills, writing good code, is the most important part of automated software testing. The tooling comes and goes, the tooling always changes, but having that foundational good programming language is what will set up everybody for success. What are your thoughts on that, Oles?
I want to also add about Playwright that it will not suit for every project for one more reason. There is also enterprises on the market that have not only web applications, but they want to also cover their mobile desktop applications. And unfortunately, Playwright is not the single tool that could cover all things in one. So they basically look to tools that could handle possibly most of their stuff and having, I would say, gold hammer to, yeah, work with everything. Like
Yeah.
we still have cases when you see on the market some jobs that require test automation engineers working with Selenium. Why? Because Selenium is working well with Appium to cover mobile and desktop as well, and as well as web. So this technology is still supported for enterprises, and it will live. I don't know for how long, but still it's relevant as well. Yeah, as we said, Royd is not a gold hour for everything.
Right. Yeah, exactly. Thanks, Solis. That's a wonderful addition. Yeah, talking about Playwright not supporting native mobile, for sure. So if you need to support native mobile, Playwright is not your tool. And in fact, I would throw this out as well. Having worked with Sauce Labs for over 6 years and having worked with 100+ customers all over the world, seeing web and mobile implementations, you don't want your web automation and mobile automation to be the same. In fact, I can't really even think of a situation where it should be the same, because I strongly believe mobile automated testing should be done using the native frameworks, which means something like XCUI Test and Espresso, because those are created by Android and Apple to test their mobile devices. And they're very nicely and tightly integrated. They're fast, things work well, and those companies work hard to support their testing tooling, versus using like something like a third party service. It becomes too clunky and too slow, like an Appium, for example, too clunky and too slow in your mobile automated testing, and it becomes extremely difficult, and I would say sometimes not even valuable in order to make that happen. So highly recommend just use the native frameworks. And if you're using the native frameworks, which means you're not going to be doing automated web testing using those native frameworks as well, so then you're picking another type of tooling. Cool. Here, let me just scroll for everybody. This is how we evaluated everything: testing capabilities, reporting, continuous integration capabilities, community and support and library capabilities, speed, and platforms. And so then ultimately the numbers change like that. Probably they will change now. This is like 2 years old, 3 years old, this POC evaluation. Probably the numbers will change some, but at the time it held true. And I think once we show you our ROI dashboards and what we've been able to achieve, you'll see that this was a very successful approach because it helped meet the customer's needs. Yes, it took extra time, but when you consider we'll be on this project for years and years, taking a few weeks to pick the right tooling and evaluate it is nothing when you compare it to the years of time that you'll have to use to support that tooling. Cool. Oles, you know what I'd love to cover next is our ROI dashboard, give a high level view of it. Cool. So let's walk through some of this. Here's what we were able to achieve for the project, which has been pretty impressive considering the project started from absolutely nothing. And now we've got, what do we got here? We got 571 security tests. So you can see in the columns, we have a before column and an after, right? Before was 0. Now we're up to 571 security tests, about 102 bugs. Total automated tests, about 850. At one point, I know we were close to 1,000. Time to execute tests. This is phenomenal. 4 minutes for us to execute a suite of 846 automated tests. Plus, how are we achieving such a fast test suite execution time of 846 tests?
Yeah, that's the capabilities of CI/CD and the functionality of Playwright as well. In combination of workers and the jobs, we can multiply, and having independent tests, I want to mention we can achieve the full parallelization and decreasing time in much times less than maybe in some other tools.
Amazing. And so tell me how we're achieving, what exactly are we doing for parallelization in CI/CD to get these kind of numbers?
Okay, having these tests in place, we have a CI/CD process. In Azure DevOps, we have hosted CI's jobs, and we can have, for example, we can have two jobs. Imagine two jobs, and these jobs have these tests. And Playwright also has a feature called sharding, and also CI/CD given us by Azure DevOps has a special feature called metrics. Metrics means that we can have multiple instances of exactly the same job, and having it coupled with sharding provided by Playwright, having indexes. What I mean is, for example, imagine 20 tests. Yeah, 20 tests. And when you specify, for example, one of two, that means that you will execute 10 tests out of 20. If you specify two of two, that will execute the rest 10 tests out of 20. And having coupled with this matrix given us from Azure DevOps, giving this matrix index to shard, a special CLI command shard in Playwright, we can separate a set of tests in multiple shards, having them in multiple jobs. As well, also we need to keep in mind that Playwright also has inbuilt feature as called worker processes. This worker processes is like internal OS operation system processes that will pick up our test. We can specify number whatever we want, but we need to keep in mind that we have restrictions on our hardware. Of course, CI hardware is not that big or powerful. So we have, for example, 2 workers in one job, and these 2 workers in 2 jobs, meaning that in total we have 4 workers. Yeah. And having that, these 4 workers picking up independent tests and execute them also in parallel. And that speed up our, imagine in one job having 1 worker and having 4 workers and all of them running in parallel, and it decreased time times or 4 times. That's why we have such enormous time for such huge number of tests.
Amazing. Yeah. I mean, what it boils down to is if you do the math, it's 0.3 seconds per test,
Yeah.
which,
If you are talking about API tests, it's totally possible.
yeah, which is that's what's happening here, which is amazing. So let me just summarize what you said. Basically, we have 2 jobs. Inside of the 2 jobs, there are 2 workers for each job, and then
Yeah, right.
each of those workers is sharding, and so there's basically 4 shards, 1 per worker. Did I summarize that correctly?
2 shards per worker. 2 shards per job.
2 shards per job, 1 shard
Yeah.
per worker.
Yeah.
Okay, so each worker has 2 shards, 2 shards in one and 2 shards in another, and so that's how
Yes.
that's happening. Yeah, beautiful. Yeah, so if we can see in terms of like how much time we are saving per day from a single automation release, it's 56 hours saved per day, assuming that each test takes about, what did we assume there? I think 3 minutes or 4 minutes, which actually the project lead commented on and said maybe that's probably on the lower end. He's like, wow, 4 minutes to execute one of these tests, that's probably on the lower end. So 56 hours per release. And sometimes we have these tests executing multiple times per day, right, Oles?
Yeah, right.
Cool.
Correct.
Cool. Yeah, so that's an amazing, and this is what we were able to do over the last 2-ish years. Ultimately, get this project. It's pretty much in a It's definitely in a continuous integration state. It's not in a continuous delivery state because this project doesn't deliver features all the time, but it's being developed and tested all the time, right?
Yep, that's true.
Cool. Then let's go down to one network for a bit just to talk about that. There we added 5 security tests, prevented 6 bugs, have a total number of 74 automated UI tests. Those are executing in 15 minutes, um, 24 seconds per test on average, and saving 6 hours per day. Now, why do you think it is that our API testing efforts seem to be so much more successful than the UI testing project?
Hmm. Why it's more successful? Because API testing is, of course, is much faster to implement and maintain. Yeah, because implementing those UI tests, yeah, very hard. Still, we have a nice passing rate, having a feedback loop in place. But unfortunately, we got less value for customer having those tests. That's historically related, I would say. But for MuleSoft platform, as it was primer and most important core over those all of the systems here, our output and I mean our input here was more valuable from the beginning, I would say.
Yeah, that makes total sense. The MuleSoft platform supports so many other platforms, and so, as you said, it's core to the functionality of the organization, and so we're putting in a lot more effort there and getting really good success over there. Cool. This is really good, Oles. You can feel free to stop sharing. What technologies, and how are we doing automated API testing?
Still, we pick a gold hammer in face of Playwright for both API and UI testing here in our organization. And in both ways, it applied well. There is also a lot of discussions currently what you should pick for API testing, especially when we are talking about JS and TypeScript stack, because in Java and C Sharp, it's clear that people usually pick rest assured. But what's going on in JavaScript and TypeScript is currently still people have a debate.
What do you think?
Well, that's a tricky question because historically, before Playwright came out, people used two different, I would say, tools in combination. They had separate test runner and API client also as separate package. Usually, it's something like fetch or not fetch or
Axios.
Axios, you're right, and running with Jest, Mocha, and some assertion libraries, Chai, etc. Jest also has its own. And people invented their bicycles, I would say, having their own API testing frameworks, inventing and customizing their own test runners, loggers, all the stuff by their own. But then there was also more tools like specialized tools. Maybe you heard about Pactum. It's like tools for contract testing, but it's pretty niche also. Usually people build their own test runners with clients and stuff like that. But when Playwright came out, they gave people possibility to have API test without browser, without everything. They have basically the same API client as not fetch, but just wrapped over test runner that Playwright have. Because Playwright test runner gives us so much powerful traceability and nice logging, it's not seem bad now to pick Playwright as a single tool for API testing. Yeah, still people can pick Playwright just only as a test runner. They can connect them to Axios or NotFetch or whatever client for API they want. But in this case, they still need to invent their loggers and stuff like that because those clients is not working well. They are out of test runner that Playwright give us. So the logs are not in place if you are running separate test client or API client. You need to invent something different. Yeah, currently I saw some open source plugins to Playwright to support different clients out of those that came out of the box. But currently the idea I'm saying now that Playwright still is not the bad pick for API testing. That's the idea.
Yeah, I mean, your logic makes total sense. It's ultimately avoiding the engineer having to recreate a bunch of stuff on their own, as you talked about the logging, the reporting, the organizational structure, the where you said it, like the configuration structure. It's avoiding the engineer having to come up with all of that and giving a solid foundation for doing automated API testing. Give us a few of your top challenges that you faced during automated API testing?
Top challenges. One of the challenges was it's might be less important, but sending these requests that support only form data. Unfortunately, when I had this issue, Playwright didn't support natively form data requests, but then they pushed a new version and they did it. So now this issue for me was resolved, but this was important for our authentication side. What else was important or challenging was maintaining the schemas for our API tests. That was kind of painful at the beginning because we managed to have those schemas. I want to mention one more important thing that MuleSoft manages the documentation in RAML schemas. That's important because still current standard most of backend engineers and during development API are ruled by open API standards. during development of their REST APIs. But here we have different story. And managing those schemas, transforming them to Open API was challenging. Still, MuleSoft has a inbuilt transformation to Swagger version 2, which is unfortunately outdated currently and not supported, like maybe in some legacy projects still. But currently we have OpenAPI 3 as standard. And the challenge was moving from having manual schemas and having dependent TypeScript types of it, having this generated schemas for test comparison, and having everything that this documentation gives us. Parameters, the types of parameters, everything that's basically described in schema, and what's possible response based on status code. And having to transform this Swagger 2 to OpenAPI 3 version and compiling this OpenAPI 3 version to JSON schemas that could be understood by our tooling, and transforming it into types was challenging part. But when we managed it, it gives us less pain maintaining manually. We deleted most of the JSON schemas we recreated from RAML, and just having this one solution for managing the schemas for testing. This one also is part of the challenges.
That was a lot. We have to unpack that.
Yeah,
That was deep.
makes sense.
Yeah, that was deep, brother. So let me summarize what happened there. So MuleSoft has their own proprietary schema format in RAML, but you can convert that to an OpenAPI version 2.0, which is outdated. 3 is the latest version. And so what you were having to do was convert the OpenAPI to specification into JSON format files to use in your tests. Did I get that correctly?
First of all, I need to transform Swagger version 2 to OpenAPI version 3
Version 3.
specification.
How are you doing that?
We have a tool basically
That you created?
No, there is an npm package that
Okay.
can help us, but
Okay.
there is some pitfalls
Yeah.
because it's not possible to manage everything by this tool. When this is some inbuilt, issue or feature of MuleSoft, because when they transform their YAML specification to Swagger version 2, they add some custom properties that could not be understood by even Swagger version 2 specification, and transform it to Swagger OpenAPI version 3 becomes impossible. It says that it's not possible. You have incorrect properties that is not out of standard. You can't do that basically. And on my side, before before transforming it into OpenAPI, I need to find out the pattern of this properties creation, what they created, and manage by separate part of code to transform it in well understood properties by standard. I can complete the transformation. And then when I completed the transformation to OpenAPI version 3, I have 2 more steps. One is transforming this OpenAPI version 3 specification to JSON schema. JSON schema. And the second one is transform those all the specification to TypeScript interfaces, modules, types, everything. And these types then will be imported to our spec files or API clients that created controllers, all the stuff, to not create different files with interfaces, but having one generated interface from OpenAPI specification, and reuse it between parameters, headers, responses, because responses could be so huge, and you don't want to have it on your own manually managing those interfaces. But now we have just one line of code importing this type from generated types from OpenAPI, schemas. And then having it coupled, we have a nice and more cleaner framework that has all time relevant information about the schemas and API implementation as well. Because if, for example, imagine if some parameter you have covered by your test and this was deleted or added something new, and you go to your IDE, and whenever you run the test to this endpoint, your IDE will say that you have an error because TypeScript capabilities highlight that maybe you using the type in your tests or some of your test sets and test data that already not exist in this type, and you should go and look and update it, and you know clearly what to target and where to go and update if something is missed or added. Yeah.
Okay. All right. Wow. What a process. Have you considered using AI for the transformation?
The AI helped me to recreate this process, but did we consider it using AI in this process? Maybe
No.
no.
Interesting. Because I would imagine with AI, you could ask it to, you get the OpenAPI V2 specification, and then ask it to create you the types of files that you're looking for, which is I guess you don't really even need the V3 specification, right? You were just really ultimately looking for the JSON spec file and your file for the test code, right? Those are your two outputs that you really need.
Yeah,
Right,
right. The
right.
basically the specification is used at the end to have those files.
Nice. That's super. Okay. All right. So you're getting these outputs. Thanks to them, you have automated playwright tests that'll dynamically understand the types that exist based on that, execute the appropriate tests. You also mentioned something about now the specifications that are being produced by you are the standard and not the RAML specifications. Did I understand that correctly?
The MuleSoft, as I mentioned, has a possibility to transform the RAML to Swagger 2
Yeah.
document. But unfortunately, this document, even if it's transformed, it's not transformed well. It's transformed with some custom properties that is not even documented as a standard by tool developers or specification standard developers, I would say. And we need to handle it on our own because it's problem, because those who write tools to transform it from Swagger to version 3 OpenAPI, they wanted to transform normal spec file, not with some things that are out of standard. They were not
They're not prepared for
adva-
some stuff.
yeah, there were cases.
Okay. Okay. So ultimately, all of that work was done to enable better automated API testing.
Yep, the work we've done is to simplify management and maintainability of those APIs, especially their schemas and schema, which included all parameters, headers, responses, all stuff there. And it saved me especially a lot of time developing new API tests.
That's cool. Amazing. And so, what does the development and deployment process look like today with these API tests? Like a feature gets created, and then what happens?
Okay. In our process, whenever a developer do a commit, we have triggering the build. This build includes packaging file, those stuff to then reuse it maybe in some release process. And also it includes testing. We included,
Automatically in Azure DevOps, right?
right, it's in Azure DevOps. Also this stage includes testing. Testing um, customer requested having specially focused on security testing. So if we are triggering build, we are doing build as well as API security tests to follow and check if everything in current build or added endpoint or feature having applied security policies and no one missed that. And having passed build, it automatically triggers the release process. How it looks, they use this build as artifact. This artifact is used then to deploy an app to hosting. Like if we are talking about MuleSoft, and whenever this deployment occurs and it's successful, right after that, we are triggering functional part of our API tests. This functional part means testing all parameters added, all parameters, all combinations of parameters, schema validations, some specific test cases related to endpoint, some some specifically related to this endpoint information validation. And having that, we have like it looking as gates, and when they succeed, all of these stages succeed, then deployment is considered successful.
And how do you decide which tests to automate for the APIs?
Usually we have a list of integrations and they are well documented. Not all integrations are related to API, by the way, as well as, they not related everything to API testing, but we have this documentation, and if this is an API integration, it added in Postman collection or having a user story specific in Azure DevOps, naming the integration, having a number of integration, and this we have acceptance criteria having the links to the stories, and this stories is developed by some business units here, having conversations how the integration should look like, how it should match with contract from system that will be integrated with. Yeah. And then when we decide to when the story moves to testing, the developer or manager send me this story, and I'm proceeding with covering this user story or endpoint or integration. And then I cover it, put these tests in place, and have it in this process that I mentioned. Build, functional, release process.
Amazing. Great work there, Oles. I have another question about that. Is the rest of the team aware of the automated API tests that are executed on every commit to the pipeline?
Yeah, we have tests, API tests here in place, and as well as special code checks. What the interesting part is, developers took more attention to code analysis part, not the output of API testing. If API testing is going wrong, then we debug the build and check if what's failed and determine if the issue was on test site, maybe something is not updated, or it's actually a bug. Yeah, this kind of little bit longer process. But if we are looking about into the build, we have special static code analysis check that also built on our own. Yeah, due to some specifics on the project, especially related to MuleSoft software and their IDE. We had a set of best practices here, how to follow them, how the properties management should look like. Based on that, we developed scripts that check the developers' pull requests and determine if they are following predefined standards according to these scripts, according to documents, and scripts check if they are following it. And based on this, the code scanned, there is at least, if I recall, 7 most important sets of rules, and we gave the output if something is wrong in file, or some warnings in the whenever they are committing to the repo or having a pull request, they done some things is not well or not following the best practice, and showing them red pipeline, and if they don't fix that, it will never be green. Yeah.
I mean,
And
that's amazing.
what it's affected, especially for me, it affected me in that way that developers started to come out to me with more questions and how to fix those issues. Yeah, having discussions with manager, with the lead, with developers of how it should look or how it would look, and maybe some having some adjustments or deleting something, but it improves us as a team, especially our collaboration of mitigating those kind of issues.
Yeah, amazing. Amazing. Really, really good work, Oles. I want to congratulate you on that. I was just thinking about this here, reflecting on everything that you're saying, and it's pretty impressive work that you were able to do. Basically, a one-man team supporting all the internal APIs for the organization, and you created basically static code analysis process. You created a functional and security testing process, schema validations, all of that happening through a CI/CD running automatically. Of course, when things fail, there's an analysis that happens, a root cause analysis to figure out whether it's a bug or a code needs to be some updated. I think we saw in our metrics caught over 100 bugs from leaking to production through that kind of process. So really, really impressive, really good work. And I love that the developers are relying on you and having conversations on how they can improve. Give us some of your top lessons, maybe like two of your top lessons that you learned for automated testing that you can share with us to make us a little bit wiser.
Okay, nice question, by the way.
Thank you.
Top lessons is not relying only on yourself. Yeah, you could be the great man, great engineer, the best in your industry, but without collaboration, especially if we are talking about testing industry, you will reach nothing if you won't hear the team or like stakeholder. That's one important thing.
Let me make a comment on that. A really beautiful statement. I love placing an importance on collaboration because from my experience in the testing software engineering space, software engineering is a very collaborative activity. As you said, you can be the best, but if you're working in a silo, you are not understanding, hearing the needs of other important players on the team in order to do your job even better. Because ultimately, whatever organization we are working for, we are all a team working towards that common goal. Whether that common goal is clear or unclear, that's up to the organization. But regardless, there's a common goal that we're working towards. And so you can't get to that common goal by yourself without taking input and collaborating with other people. So collaborate. Don't stay in your silo. Get out there, talk to other stakeholders within the project, understand their needs. And by understanding their needs and fulfilling their needs, you will actually get more support for your initiatives because they believe in you and they will love you more. And ultimately, it'll allow you to progress faster through your career. It'll get you more promotions. More people will value you, and everybody wins by more collaboration.
Yeah, totally agree. And one more lesson is don't be afraid to go further your scope of responsibilities. What I mean is, as we shown now, the static code analysis was primarily not in place and no one were interested in it. Like maybe a couple of people or even one people, like our lead. He want the developers to code properly, but the developers don't have a time. Just they do their work, they are okay. If something is will be on surface, then they will be responsible for it. But if you put more effort and if you want and don't be afraid of it, you can give more value to the organization or company, as well as be a more valuable team player. This is also related to our previous lesson.
So going above the scope of your responsibilities and finding areas that you know you can improve by putting in some effort there, right? Yeah, totally agree. I mean, as a you spoke about it as an individual contributor perspective, which I love and totally agree. I'll speak about it from an organizational leader perspective. There are like levels of people that we work with, and as leaders, we view them on these kind of different levels. There's like the very low level, which is basically like a person that only executes the tasks that they are given. And if they're not given any tasks, they don't execute anymore. Those are the worst types of employees because it means you need someone there to give them work in order for them to proceed forward. And then at a very high level, there are people that understand their role and their responsibility within the organization, and they will pursue achieving their goals and responsibilities on their own by seeing challenges and solving those challenges within the organization. And they will never stop because the challenges and the growth, especially within technology organizations, never stops. And so those are the highest level people. And those are the people that I love working with, is that you just give them a role. Hey, this is your role. You're an automation engineer. This is what we're doing. This is the organization. These are our goals. Go. And then that person executes. Like, those are the people that organizations want. Those are the people that organizations will hire. And if you're that type of person, you will prosper very well in your career.
Yeah, you're right.
Yeah. And that's why you prosper very well in your career, Oles. That's why I wanted to have you on, because you're a rock star.
Thank you.
Yeah, you're welcome. Well, Oles, any other last words of wisdom you want to leave us with before we end our interview?
I think important thing is at the end being yourself and promoting nice engineering culture, but doing not only it by yourself, but coupling with team, and all team have common goals. You have to promote, or at least try to achieve, a nice engineer culture in your company, project, organization, and whatever. Yeah, to having best results and collaboration, not having a separate like units of in development process, like developers, testers are living independently. Business representatives, they all don't understand each other, having lot of common goals, but not a common understanding of achieving those goals. And everyone working as one big organism, that would be a key to good software production, to good software development, and having a nice output and results for all stakeholders and teammates.
Beautiful. Thanks for sharing that, Oles. Thank you so much for your time. Thank you for all the amazing work that you've done. We really appreciate you, and have a beautiful weekend and rest of your week.
Yeah, thank you. Have a
Yeah.
nice week too.
Thanks. Bye bye.
Bye bye.